All right, we are live, so to speak, or at least live recording. Yeah, Drew, thanks for joining me today. Really excited to learn about you, and also, of course, HoneyHive, and then discuss in detail our topic at hand with evaluations. Automated evals, man. It's a challenging problem to solve. Necessary to build out systems with sufficient complexity, especially in multi-turn systems like AI agents, where of course those LLM errors can compound over time with each step. So setting the stage for our audience, the list of questions and talking points I've got are designed to provide perspective and insight for AI engineers in the way that Sean Wang Swix famously defined them in the Rise of the AI Engineer essay. So it's going to be full stack engineers who are learning how to leverage LLMs and related technologies to build full stack GenAI powered applications. So that's a long way of saying for folks out there that are watching this, there's not a strong need to have a traditional data science or ML background to get a lot of value out of today's conversation. Also, this is going to be super casual by design, but just to add some structure for the folks who will be watching. Drew, before we dive into the questions, let's just give some really quick background on ourselves and our respective organizations. So a little bit like the first day of class, so to speak. I'll go first. My name is Reid Mayo. I'm a founding AI engineer at OpenPipe. We are a platform that makes it super easy to fine-tune large language models. So both open source and closed, big and small models, and we support the full end-to-end process. Data collection, selection and refinement and improvement, actually processing the fine-tuned jobs, evaluating the fine-tuned models against each other to surface the highest performance one, all the way through a hosted inference as well on fine-tuned models, but that's for our users' convenience. So, there's no locking on that front. And then going a little bit deeper into my personal background, I've got a lengthy background as a senior full stack engineer. I've been pretty heavy into the GenAI space for about a year and a half now. Before OpenPipe, I co-founded and built a senior full stack engineering agency. I grew that to a team of 25. A great experience in leadership. I was lucky to work with incredible engineers, incredible talent, but it's a lot more fun being closer to the tech these days, especially working in a novel space like GenAI. And then also, Drew, before I let you kind of share some insight into your background, just want to tell people the best place to reach me for anyone out there interested is over LinkedIn. So just send me a connection request. I'm super friendly, love to chat to anyone, love to teach anyone, and love to learn from folks. So yeah, man, go for it. Drew, can you give us some background on yourself and HoneyHive?
Yeah. No, first of all, thanks for hosting this. This is really cool. Getting to talk about evals is really fun and really boring and really important because
I love that description. We're gonna make it super exciting.
Yeah. No, I think you can't talk about it enough is how I feel about evals. It's always the veggies that no one wants to eat, but everyone knows they have to. That's how I feel about evals.
Yeah, for sure.
Yeah, but quickly, so personal background on myself and HoneyHive. First of all, HoneyHive is like a observability and evaluation platform for AI applications. So idea is basically anyone who's building an AI app wants to figure out like what's going wrong, where wants to run like CI tests, production observability, that kind of thing. We just orchestrate the development workflow and make it easy for people to build like complex AI apps.
Awesome.
So just think like everything outside the deployment layer actually. So just, making sure you have all your ducks in a row and all your evaluators are passing, etc. Now, personal background on me. So I started off in GenAI actually at Microsoft back in 2021 when only Microsoft thought GenAI was a thing. And everyone else was everyone else
was a lifetime ago. 2021. That was before November 2022. Whenever everyone realized that there was this big thing under the surface lurking.
No, I mean, dude, I had like a 1 hour conversation about the philosophy of science with an AI in 2021, and I was like, what? I think that's just like, where have we ended up? Which tech tree are we on now? That's how I felt about
that's
it.
Awesome.
But back at Microsoft itself, I started building prototypes of like coding agents with the OpenAI team in collaboration back then. And I pretty quickly realized it's like a very new form of tech, very new kinds of best practices are going to emerge, new ways to evaluate, new ways to monitor. Just like it's just this open-ended problem of how do you tune an intelligent system? Like it's like previously in software, it's like you have a very deterministic thing with very well documented handles on everything. And you're kind of entering this domain where anything could happen, but it's roughly going to be intelligent. Like You just like, is this Bird plus plus or is this AGI? Like, you're always
Yeah.
kind of in your mind balancing between the two. And
Yeah.
yeah, so I think we started HoneyHive, me and my co-founder, who was my roommate in college, back in
Oh,
2022. And we got started, pre-chat GPT in the prompt days, and now we're
wow.
in the agent days. So yeah, kind of seen this space go through its motions.
That's awesome. I had no
Yeah.
idea that y'all were pre, Chat GPT launch. That's really cool. Absolutely agree with what you were saying. I mean, the big paradigm shift here for me, coming from like just a traditional software engineering background, is software engineering, everything's deterministic. You can understand it. You know what it's going to do. There's no surprises. And if you're a junior engineer, there's lots of surprises. But you get enough years under your belt, everything is completely understandable. Massive paradigm shift in building with LLMs and GenAI. It's everything's somewhat non-deterministic.
Yeah.
Obviously you can kind of pull levers to make it more not
Yeah.
deterministic and less and more deterministic. But that to me is like the big paradigm shift that was both challenging and also interesting for me to pick up. And like I've tell people, like, to me, LLMs and GenAI are the first novel thing in software engineering basically since I started doing this. It's just there's really been nothing like it.
Yeah.
It's super fun, but super challenging. So speaking of challenges, Drew, thanks for that intro. Let's go ahead and like dive into it. So I've sort of structured the list of questions here to start with the basics and then just like layer on complexity as we go.
Yeah.
So yeah, let's start with the basics.
Cool.
What is the most basic question you can think of here? I'll launch with it. Drew, what are evals? Why are they important? And you said they're sometimes boring to talk about, sometimes exciting to talk about, but like mission critical and fundamental. What's going on here?
Wow. It's the term evals is used in many different ways in this system, so it's this kind of like a landmine question, I feel.
Sure.
But I think ideally we should have had clarity on this a while back. But anyway, best practices early days. Okay, at least the way I think about evals is making sure that your application is within certain performance expectations. Like, I guess on a very general level, that's what
Yeah.
evals means, just kind of generally across domains. That's like, I have some expectation that, when the user does these kind of things, these kinds of issues won't show up and this kind of performance will be expected, right?
Okay.
You can quantify this via SLAs in the case of software. In the case of machine learning, it's via like loss functions and F1 and so on. In the case of GenAI, it's more like, for these kinds of user inputs, make sure that these assertions are always passing. The AI is mentioning something about this. The AI isn't mentioning this in an incorrect way. The answer doesn't have hallucination, etc. So what evals is at that point is like your understanding of what the user's needs are, that being your data set that you're going to try to test against, and your understanding of what the user's expectations are of what the responses should feel like or should exactly be like, and encoding that via like subjective evaluations or objective evaluations. And so having that kind of a harness against your system and then continuously running that kind of through the life cycle of your development process, that's what I think evals is. There's a lot of open questions now.
Sure.
As we
Yeah.
like all
Yeah.
over the place over
Yeah.
here. Like, I think the boring part of it is, I think the problem with AI is it's too easy to build a good enough prototype, right? Like,
Right.
it's a
Yeah.
general intelligence, so
Yeah.
you could just throw whatever you wanted at this model and it would give you some answer, right? Now,
Yeah.
whether that answer is useful, meaningful, who knows, right?
Yeah.
But you can throw something at it.
Yeah.
This wasn't the case in software, right? In software, you
Yeah.
really have to think about the API. You need to think through what expectations are for what's going in, what's coming out. You can't even build something without knowing what you're building, right?
Yeah.
Like, it's impossible.
Yeah.
AI, it's not the case, right? It's general intelligence, quote unquote,
Yeah.
right? So you could just be like, hey, we're going to build a summarization, right? Like some team somewhere is like, we're going to do summarization. Now, here's what you can do, right? You can just be like, the prompt is summarize that.
Right.
That's
Yeah.
the prompt.
There's massive variance here in
Yeah.
quality of,
Yeah.
which is why it's
Like,
so easy to, like whip up a demo in a weekend, but
yeah.
everyone is killing themselves trying to productionize this stuff and
Yeah.
build something you can actually trust and your users can actually
Yeah.
trust.
And the reason for that is no one's thought through the specification, right? No one's really thought through what kinds of inputs do I want my system to handle? What kinds of outputs do I realistically want it to generate? What's the domain of good and bad? Like, no one thinks about that. They're just like, yo, we'll throw this in prod, we'll set up a feedback endpoint. People say like, dislike, and we'll roughly know what the hell's happening. And like, if more likes than dislikes, we build something useful. Like, that's kind of the go-to mechanism here, but it's lazy engineering. Like, even in software, there's everyone can be lazy engineering at any point. Like, you can just be like, try catch pass, like, we will take care of it, at some point in the far future. So it's like much worse because it won't crash. The user will still get like, somewhat bad output.
Right. But
if you don't actually, exactly. Is it actually useful? And the thing is, because people don't have clear evaluators, they don't critically think about how do I measure what good looks like.
Yeah.
They don't realize that their application's not good until way later. Until like what we've seen is like, vertical AI layer startups, like someone will spin up a GPT wrapper and they're like, for a month, it's like, wow, crazy growth. Like, wow, everyone loves it. And then, a month later, everyone realizes this thing doesn't work.
Yeah, it's a toy. It's a toy. Yeah, it's a toy. The edge cases start popping up, they start exploding, and then the errors start compounding. Everything you were saying was fascinating, but something that really stood out to me was you started talking about evals almost in two different, like, I won't say philosophical camps because both of them are necessary. I think of evals kind of as like quality control, total quality control. You evaluate everywhere and you make sure things don't fall, run off the guardrails here.
Yeah.
You talked about that, but you also talked about thinking about evals as modeling your system. What type of inputs do you expect? What type of outputs do you expect? And then, of course, building, it sounded like you almost build the architecture of your technology somewhat conceptually with an evals harness, if I'm hearing you right.
Yes.
So my next question here, which actually kind of feeds into that pretty good, is, when should I consider adding evals to my GenAI stack? Like, is it mission critical? Is it nice to have, not need to have as I'm building a POC? Like, I mean, you talked about like whipping up POCs, but then everything falls apart pretty quickly. It sounds like it should be like the first thing that you think about, at least.
Yeah, I mean, this concept that I propose, it's called eval-driven development. A lot of people talk about it. I think the thing is, here's the difference between, in software, TDD has been a thing, like test-driven development, and like, senior engineers get that this is important. Junior engineers learn the hard way that this is important. It's kind of different in GenAI because, as I said, like as you caught on as well, your eval is what you're building. Right? This is general intelligence you're working with. So if you don't tell it precisely what you like and what you dislike and what kinds of things it needs to perform well at, it will just do whatever. It's a creativity machine, right? Like it'll just be like, hey, the developer who built this prompt system agent or whatever didn't really think through whatever edge case that this user is giving me. So instead of, in a sane world, your prompt would include something like, if the user's questions are relevant, just say, I don't know, or this is not relevant to me. Ideally, there would have been something like that. But most of the time, it's not. Or maybe the AI misjudges that, oh, this question's in its domain, right? And people don't even eval that, but that's a different issue. But let's say something new comes from the left field to the AI, it will just try to rip because its RLHF dictates that it needs to make sure that the human enjoys the conversation, but does not dictate that the app is reliable. That's not what it's been RLHF for. It's been RLHF for just riffing with people. So then in that kind of a world, it's like, when should you consider evals? I think there's like different kinds of evals. Like first, you need to do this kind of exploratory eval where you're like, okay, I generally know what kind of feature I want to push for my customers. You just run stuff in the playground, just, throw different inputs at it. And I feel like a lot of the early part of developing an app, the model is teaching me what's possible, I feel. Like they'll just start doing stuff that I didn't even think it could do. And I'm like, wait, should we productize that? Or the thing that I wanted it to do, it's not able to do reliably, but it can do it if I constrain it really tight, what I want, then it's able to do. So that initial eval phase is very exploratory. There's nothing really in code anywhere. Nothing's like kind of committed, but that eval is just like vibes and getting clear on what you want the thing to do. And then once you've clarified what you want the thing to do, then you should introduce evals at the beginning, immediately ASAP. Now, of course, I know people won't do that because it's not fun. it's not sexy. You know what I mean? Like, you know what's
Yeah.
sexy? Like I shipped this demo over the weekend. That
Yeah.
sounds cool to people, right? And then we'll just
Yeah.
throw it in front of a user. The user will use it like 3-4 times. Like it kind of works. And then they're like, yeah, let's take this to prod. Like, that's
Yeah.
really what happens.
Good luck. So Drew, if say that I'm totally convinced. And by the way, you didn't have to convince me because being a senior engineer that's been around the block,
Yeah.
all about. I actually have
Yeah.
the problem of over engineering up front. Typically, I have to like tell myself like Reid, like chill out with the tests, actually start driving stuff forward. But I totally understand your philosophy here on modeling the system with evals because LLMs and GenAI are so loose and general purpose. You've got to put some focal points on here, else you're all over the place.
Yeah.
What are some of the different types of like fundamental evals? I hear like direct scoring evals, pairwise. Like what are your thoughts there on like the fundamental eval types that people are using and which ones are like useful, which are less
Yeah. Yeah.
useful, and what are the use
Yeah.
cases maybe?
I think Eugene Yan has already done a very brilliant job. I just want to call that out at the
Love it.
beginning. His post on this topic is just like gold standard stuff.
Yep.
I think my thoughts are like very mirrored with those. So I think, first of all, like, as much as possible, whatever evaluators you have, I think should be deterministic. So what I mean by that is if you want the model to do something, let's say summarization, data extraction, those kind of things, you should just have something like a regex check. I think regex checks are like a really good way to get started. Like, don't mention these kinds of things, mention these kinds of things, etc. Like, so those are the kind of like initial kinds of evals that I see, which is just like sanity checks, right? Sanity checks, deterministic checks, just make sure we are doing something that roughly makes sense.
Yeah.
Then you kind of get into like the assertion checks or like, criteria checks kind of thing, which is here now you need to start tapping into some model's intelligence to check what the hell's going on. Here now with criteria checks, you're getting into assertions where you're like, does the answer follow the prompt, right? That's very simple eval. You start off with that. So then you go from the more deterministic regex reliable ones, then you go into slightly more non-deterministic evals. But there you need to do your best to kind of like really, really nail down your eval prompt. I see so many bad practices with eval prompts. I mean, like all over the place. Like people just use them. Yeah.
What are some of the best practices for these eval prompts? Like, is it like if you're trying to stuff too much complexity into one prompt, like decompose it, rip it apart, maybe have like, I don't know, one LM eval prompt for each specific criteria that you were talking about?
Yeah. No, exactly. I think you need to really, really tightly scope the criteria. As you said, like have one LLM do one criteria at a time. And the criteria that you have, really critically think about how much creative freedom are you giving the LLM with interpreting your criteria. Like, is your criteria something like, oh, it should sound good? Dude, like, it's going to do whatever, whoever OpenAI. Yeah. Like, when you say to an LLM, tell me if this is good, what you are asking is all the annotators that OpenAI, Anthropic, and Google have hired to RLHF my models, do they find this good?
Yeah.
That is the claim you're making when you say, are you asking an LLM, is this good? Because these LLMs have, that's the annotation data they've been aligned on. So they're going to hook up to whatever persona aligned this model, the general purpose model when it was built. So what you really need to understand then is like, when you ask an LLM, hey, this is good, is like, you need to understand who is my user? What do they want? What are their clear requirements? And then you need to be like, okay, and good means blah, 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 blah. Like this one is user. This is kind of what they want. This is how they want it. And then give it positive example, negative example. So just standard LLM best practices, few shot it, give criteria. And very critically, I think Eugene talks about this as well, like binary criteria as much as possible.
Yeah, he talked about that.
Yeah,
mainly because of classification metrics. Like he said, it's just easier to measure.
Yeah, and the thing is, LLM is a little too much like a human, in my opinion, right? Like when I ask someone, like, hey, can you rate this thing on 1 to 5? What do people do, right? They're like, oh, I give that a 5. I really like it. Like, there's no calibration in that scale, right? It's just like the feel of it. And then, so, I think there's a few studies been where you check for different models, how well do they distribute across scores and how aligned they are at ranking 1, 2, 3, 4, 5 to 7. and they're just like all over the place. Like it's very biased towards certain scope, just like people.
It's just too open-ended.
Yeah. So just like scoping down your big criteria into a bunch of binary criteria. And then what I do is then have a hierarchy of importance on these binary criteria of like, first it must pass this, then it must pass this, then it must pass this, so on and so forth. And so then you kind of end up with this like eval set, which is like some deterministic checks for sanity, then some very scoped down basic assertion checks from an LLM, which do specific things, and then priorities on each one of them. So you kind of have a well-calibrated score. Now, this though, I'm gonna now, we're going now I'm gonna take one abstraction level higher here. This is for a single step eval, is the way I like to think of it, right?
Okay.
You have some step in your process, in your AI application somewhere, where you've embedded some intelligence. The moment you put intelligence in any part of your application, you need to set up evals. It just has to happen because intelligence is general. It'll start riffing, like, like it wants to be a jazz musician, like when you're asking it to be an engineer, right?
Yeah.
So then you'll have it, give it guardrails, and so that's fine. But now when you get into the multi-step flow, I think you hinted at this earlier in the conversation regarding the multi-turn stuff. But so there's like multi-step applications, which is like RAG.
Yeah.
Hey, let's get some data from somewhere. Let's process it once, twice, thrice, give it to the user. And then there is agentic applications, which are like multi-turn instead of multi-step. But it's like you do something, user does something, you do something, user does something. And then, so that's like multi-turn, like you're going back and forth, back and forth.
Yeah.
I see these two architectures as like kind of canonical. Like you see these repeating patterns often. And so now with multi-step evals, you now get into this next layer of complexity, which is, okay, let's say each step now I've like evaled it. I'm like happy with my evals. I've like, oh yeah, another quick point on the eval, single step eval, the inputs that you're testing against for those criteria, make sure they're simple, make sure they catch where your evaluator is bad. That's the whole eval gen stuff, which I'm not going to get into. It's too complicated for now, but yeah, there's just like some sanity checking you'll have to do on your LLM evals. So make sure that they're like saying something meaningful. So yeah, in multi-step, I think the biggest complexity jump there is just like, as you said it, right? Like errors compound. Catching compounding errors and setting up evals for those is very, very tricky, but you have to do it if the application's critical. If it's a non-critical application where the user can just be like, yeah, I don't like this, restart, then it's fine. Maybe you could get away with not doing that eval. But,
I'm curious, Dhruv. So like, I'm almost thinking, and this is my full stack background talking, but it's almost like, you talked about the single step and evaluating that single step. You talked about almost the cascading layer of evals. And actually, I want to confirm that. So when you were talking about like the sanity checks, like regex, and then layering on more complexity with maybe judge LLMs, you're talking about like a cascading series of evals on potentially one single LLM call. Okay, cool. Yeah, so you cover all your bases. You start with like, regex, then you jump to, assertion style, almost like unit tests. And then, of course, use a judge LLM to evaluate the more abstract things, potentially like regex is concrete. The judge LLM might be evaluating the more abstract features of the output. So that's like one single step. But whenever we get to these multi-step workflows, I imagine we want, and correct me if I'm wrong, but I imagine we want like that cascading series of evaluations on every single step. Those are almost like our unit tests. But then we probably also want an overall, like an integration test over the entire workflow where, for example, catching hallucinations, I know that's kind of challenging. We'll talk about that later in the conversation. But, if like step one, maybe step one failed and we didn't catch it, and we got to step two and step two was successful. But then we have like the overall like integration test, like, hey, did this system work? At least maybe then we can catch if the system failed, we might not know which step it failed in, but we could throw it out maybe and then like regenerate the entire process or loop. Is that what people do? Like, I have no idea, by the way. I'm just kind of like spitballing here based on how I would approach it.
No, I mean, that is how people approach it. So at HoneyHive, we do tracing, right? So tracing is kind of this process of capturing all those steps and then being able to visualize that after you've run the application, and then finding for each specific step, as you said it, right, those unit tests that we've kind of set up on each step, people just go through it and then see like, oh, okay, so this passed, this didn't pass, etc. Now, getting the whole check on the end-to-end system right now, it's, if I'm being completely honest, is manual.
Okay.
It's not that I just think LLMs aren't really good with really large context evals.
Yeah.
Like if you start throwing like traces, like I've done this a lot, right? Like I'll take a trace of a multi-step application in our platform and I'll throw it into an LLM and be like, what happened? Like, it gets so lost. The LM gets lost so quickly. It's like, it starts thinking it's the application. In the middle, it'll be like, so yes, so the next step that I would do after these steps is like, no, dude, don't, like, I'm like, just tell me what happened in the steps. But then,
Yeah.
because it's so large, the context, it just, there's so many tokens, it just gets distracted midway. It's like, I am the application, I'm not analyzing it. And then, so there's like a lot of massaging that we are doing at HoneyHive right now to like, make LLMs easy, like make it easier for them to understand multi-step traces and groups of traces and stuff, because it's just a lot of context data for LLMs to process when you're taking like a full multi-step eval. Like in practice, technically, I think the simple things people do is they just rely on the evals of the final step and consider that an integration test. They're like, yeah, if you made it this far and you didn't pass my unit tests on the final step, you probably did a bad job. But that only holds true for multi-step applications like RAG and multi-prompt systems. Is not true at all for agents or multi-agent systems.
Okay.
Because in agentic systems, it's like, it's a trajectory. Like the LLM is just doing stuff and it's going around and trying stuff. Like maybe it accomplished the user's intent like 5 messages ago, right? But it just didn't realize that it did, and then you end up at the last step and the AI is like all confused, like, oh, maybe I should ask user for more clarity or something. And if you just run the eval on that step, you'd think, oh, my agent failed. But actually, the midway trajectory, there is some points there that it actually accomplished the user's objective. So when you get into agents and multi-agents, you get into trajectories. And then when you get into trajectories, there's a whole different class of evals that show up, which no one in the ecosystem's talked about. We've done a bunch of work at HoneyHive related to it, but it seems like the ecosystem's not like ready for it because they're still doing evals on steps. But trajectory evals is really where, like, I think once the RAG becomes reliable, which will take about, I think, famous last words, 2 years.
Sure.
Right? I think 2 years, maybe it'll become like reliable enough, context windows get big enough, precision will be good enough. Like people will be able to just throw tons of data at LLMs and get something useful out of it. I think we'll get there very soon. Then I think the bulk of evals will move to trajectories and, understanding what paths is the AI taking to solve problems and evaluating those paths. And that's a way more complex problem. We can talk about that if you want. But
yeah, I'm actually pretty interested in diving into that because I've never even heard of the concept of trajectory evaluations, but it makes complete sense to me. I mean, like you said, no one's talking about this. I know it's a really hard problem. Maybe it's not super solvable with today's technology or techniques. Like, how might you optimize as best possible? Like you talked about this AI agent that's doing its own thing, maybe to accomplish the user's objective, but then like kept going because it's like the agent ultimately at some point needs human feedback to know whether whether it's on track or not. Is that like the path? It's just like regular when you're productionizing this stuff, it's just like regularly checking in with the end user, or like what's the best practice? I know that it's all this like super experimental also.
No, we've thought a lot about this in our team. Productionizing trajectory-based systems is a really hard problem. I don't think people have realized how hard it is. They've just like free-winged it into prod. And, that's why most agent applications are a meme right now. But, when we're talking about, AI creating like trillions of dollars of GDP, when I hear that, I'm like, I see like giant multi-agent systems doing extremely complex and sensitive stuff. That's what that number means in your mind, right?
Right.
But I'm like, dude, Evals is so far behind. We ain't no way getting there like soon. Like, I don't not see that path right now for people because we're just like, I think Evals has become the second-class citizen and like people kind of hate it. But I'm like, no, this is what you need to get there. Like,
that's what I'm going to say. I mean, it's a fundamental building block because if you can't measure quality, if you can't measure success, you can't build
anything can happen.
Mission complex. I mean, like literally, there's no, you can't direct anything. To me, it's like
exactly.
the fundamental building block for almost all complexity.
Yes, exactly. I agree. And especially with intelligent systems, right? If you're embedding, breathing life into the machine, right? You're like
Yeah.
giving it wings, like just like, give it like guardrails too. Like, hey, you can fly around in this area, like, but don't, fly too far. But if you don't have any evals, just keep flying. Just,
Yeah. Yeah.
they'll go anywhere at once. So I think going back to the trajectory thing, I think, so we're kind of in this in-between early days phase of AI is how I think of it mentally, where we're still trying to make single step work. We're still trying to make multi-step work. It's kind of becoming reliable in some domains. It's like not reliable in most domains. But again, I think this is just like, people building PCs in the 70s. Like,
Yeah.
I see the path. Like, eventually we're going to get to internet scale infra and this shit's going to be running everywhere. But so let's leapfrog in our imagination. Now multi-step is solved. Now, when you are running into these systems which are doing these complex multi-turn stuff, you need, in my opinion, simulations. Okay. So simulations is a concept that we've used simulations at HoneyHive to test trajectory-based systems, which are multi-turn. Because, so there's two ways to solve the trajectory issue, right? One is the way you pointed out, which is as the AI is doing the thing, the user's watching it. And then the user will intervene, or the AI will ask the human, like, hey, dude, I'm stuck here. Do you have any feedback? Can I do something better? Can you give me the API keys? Whatever. Like, the AI might have to just loop in with the human to get some context. But this is not true AGI. Like, true AGI, I tell it, go do the thing. Just does the thing. It's like, yo, it's done. If it needs feedback, it'll also ask for feedback, whatever. But the thing is, if you don't do a lot of simulations early on, what you'll end up having is a system which has to keep intervening with a human very regularly. And the human will have to give it a lot of oversight because it's just not been tuned very perfectly to solve those kinds of paths. Like, so the idea behind simulation, the way we think of it, is how do you gain certainty and confidence in your trajectories? You run a lot of trajectories. That's it. Like, just to run the system through like many different versions of what it's supposed to see in production. You create different environments and you let it rip in those environments. And then you analyze the trajectories that it took in that environment and the guardrails on your trajectories. See how often it hits the guardrails. See how often the performance is satisfactory. And then based on that, you will also know, oh, in these domains, my agent can do a really good job. In these domains, that can't. And so when you go to production, you will know. You're like, it's like, the best analogy to think of this is self-driving cars, right? Like self-driving cars, they have simulated environments that they train in and they're tested in. And so, if I simulate SF roads, I'm not going to go drop my Waymo in like, Indian streets. Like, dude, not going to have a good time. Like, I'm telling you now. Like, it's just the diff in the environment that you have seen it working and where you're going to put it later on is too big. So that's like the rough TLDR of like multi-turn trajectory-based systems. Like, you basically need to create different mock environments and just let these agent systems, multi-turn systems rip. And you also need to create simulations of your users. The user simulations can be very simple, like just a deterministic like playbook of like, first the user will ask them to do this. Then 3 messages later, the user will ask the agent, hey, can you do this differently? So then your evals will start looking like that, where you're trying to simulate the way it interacts with the environment and the user, and then testing those.
So I think I get the concept where it's basically just run a ton of different simulations, see what's ultimately successful, see what's ultimately failing. The stuff that's failing, you go in there and you patch it up. That still begs the question of, again, why evals are the fundamental building block. I mean, the problem here is like, how do we automate the feedback in the sense that, you run a million simulations. If the AI is not confident of what's ultimately successful, which trajectories are successful, which aren't, we need humans to go in there and basically manually score this stuff. Hey, this was successful, this wasn't, and so forth. But of course, that doesn't scale if you've got humans involved. So are we back to the same problem here?
No, brilliant question. I think the scalable oversight problem has like 2 pieces to it. I think in the trajectory case, I think it's going to be easier. Hear me out. Like, it's going to be easier because, see, right now AI is in this weird in-between phase where we're not giving it too much control over actual systems, right? We're creating these mock situations and letting it do its thing, and maybe the user gets some value. But well, let's say, pick an actual agent. Like, let's say I have it go do my software engineering for me. I go have it do my taxes for me. There is a very clear, definite outcome that can be measured there, which is not subjective. Like, if I have an AI agent doing stock trading for me, the trajectory eval is how much money is in the bank account, you know? Like,
Right.
there is a very clear end outcome, which is very measurable. Like, I feel like a lot of this eval problem happens because there is an actual metric, which is like whatever user engagement, user satisfaction, whatever people have metric. And then you create a proxy metric, and then you're always trying to align the proxy metric with that one. Now we have this additional problem where the human eval is there. And so now we need to align the human eval with the automated eval, and then align the automated eval with the end user metric, right? I'm just
Yeah.
saying what will happen in the multi-agent agent trajectory world in the far future when AI is super reliable. We'll
Yeah.
just go for that end metric
Yeah.
directly. Just like
Yeah.
skip all the steps in the middle, all this alignment stuff. We're just like, dude, I know what I want. Just go. I'll give, my AI access to my post log. And I'm like, you see that down ratio? Like, send it to the moon. Like it's so much easier because then the AI can apply its intelligence. It knows its exact eval is the end metric that the business cares about. And it can go optimize that. Right now, AI doesn't have that capability. So then I have to create these proxy metric on a proxy metric. And then I have to like scope it down, make sure the proxies are aligned. So that's my intuition for, I think the eval problem will get drastically easier the more AI becomes human-like and intelligent in the way that we are. But we're in this weird in-between phase where it's like, magical pony sometimes works, sometimes doesn't.
Yeah.
So then we
I think
need like, yeah,
I was just going to say, I think ultimately it's about focus.
yeah,
If it's true agentic outcomes of, I either got my taxes done or I didn't, I mean, it's almost back to what, Eugene Yan was saying about binary classification. Did it succeed? Did it fail? Whereas the in-between is all the fuzziness, so to speak,
yeah.
that's occurring.
And
So yeah, getting a little bit more down to earth here and concrete and kind of reducing some of that
yep,
fuzziness today.
yep,
You talked about the unit test type of assertions.
yep,
I think
yep,
those are pretty immediately clear to folks. Talk to me about using an LLM to judge the output of other LLMs. What's the state of that today? Like, how do you optimize that? I've heard
yeah,
people talk about like, obviously there's prompt engineering, of course, with prompting the
yeah,
judge LLM prompt, but then people also talk about like having a specialized, fine-tuned judge
yeah,
LLM, or for example, doing like a jury pool of LLMs where like a bunch of different LLMs judge the,
yeah,
run the ultimate evaluation and then like they just vote or something like that. Talk to me about some of the best practices there, what you've
yeah.
seen works, and maybe what's a bridge too far based on what HoneyHive has seen with your customers or just even your extended network.
Yeah. No, I think so. We've had the great privilege of working with like extremely sophisticated agent teams. And
Awesome.
let me tell you, their evaluators aren't just a single LLM call.
Yeah.
Okay. It is an extremely complex multi-step pipeline. That's how they run
Yeah.
their evals, right?
Yeah.
They don't just like, I don't think I think the fact is you can't rely on a single LLM call. So doing a jury on it still doesn't make sense to me. Like, it's
Huh.
just either way, it's like both are unreliable. Now you're just like maybe more certain about the unreliability, I guess. But like, you're just trying to get one LLM step to do too much thinking. That's the fundamental problem there. So what these agent startups have discovered is, let's take our logs and then we will break down the eval that we wanted to do into many steps, into multiple pipelines. And then
Yeah.
they run those pipelines side by side. And then they judge all of the outputs of all their prompts in the end and then give a final score. So that's realistically production grade evals. That's what I've seen. And so you have actually a separate team working on the eval application. That's
Right.
how real evals are done. I think the folks who actually care about performance end up dedicating 2-3 people just to work on that final eval pipeline application so that it actually starts giving you numbers, which mean something.
Yeah. I was going to say they're actually useful and reliable. What
Yeah,
does that
yeah,
pipeline typically look like? Like, and maybe we have to rewind a little bit here. So you've talked about, evaluations at the end of the day, prompt input, LM generates a response. Evaluation is, was that good or not? But was
yeah,
that good or not, of course, is a really loose way of saying it.
yeah,
Realistically, you started talking about criteria, which to
yeah.
me, I think it's like different dimensions of
Yes,
quality or
yes,
consistency in this output
yes,
or this generated
yes,
response. And then you also talked about read, shard that, rip it, to pieces. Don't have like one big massive
yes,
prompt that says like, is it good? Was it factual? Did it cover all the pertinent information? So you're talking about a pipeline here for the evals, almost like a multi-step workflow on the eval side. I guess first I should ask, are they typically independent? So it's like one check runs, was it factual? One check runs, was the sentiment what we desired? Talk to me about what those pipelines look like in the real world, with these customers of yours that are building really complex agents.
Yeah, so I think the kind of simple checks, as you put it, I think those kind of run all the time. They're just constantly running when they're running their tests, so on and so forth. The eval agent, like that's what we like to call it within our team. Like every agent team will build an eval agent, which will look at the other agent's trajectory, and then it's an agent which goes through it and then evaluates whether it did a good job or not. So that's how these teams approach it, is they basically run the whole agent with all the checks on each step. And then they wait for the agent to get done. And then the eval agent comes in. And then it looks over the logs, the traces that have been generated. And then goes through it step by step, reasons over the thing, and then sanity checks. Like, oh, okay. Like basically each team has like based on their experience playing with the agent, like 5 kinds of failure modes that they've seen. Like, oh, my agent gets distracted by this, or my agent doesn't ask for feedback around these issues. Or so what they'll do is they'll tell the eval agent, hey, from playing around with the agent, we've diagnosed, these 6-8 kinds of issues that come up often. Here's a trajectory from production that my agent has done. Go over this trajectory and reason about these criteria, and come out at the other end after reading the whole thing and reasoning about it, and tell me, roughly speaking, was that issue detected here or not? And give a justification for why. And so this is getting into the trajectory eval thing that we were talking about earlier.
I'm fascinated.
Yeah, so they basically do this kind of trajectory eval. And initially, so this is a really cool thing. Initially, the teams that we were working with were doing this post-production, okay? They waited for production agents to finish running, and then they ran these agents over their logs in HoneyHive. But after they tuned that eval agent and got it good, where they started to trust what the eval agent was saying about the original agent, they started running it in production. So what started to happen, so this is Multion's agent queue paper, if you actually look into it, is they started to run the agent in production, and then the eval agent would be their test time search verifier. And so what they would do in production is the agent would come up with 10 actions at each step, or 100 actions at each step. And then the eval agent would determine, let's go with that action.
The best action. That is fascinating.
So that's how then Multion started leveraging test time search, which O1 is also based on. And so after they tuned their eval agent and they had a verifier that's reliable, they then got it into production and then started leveraging test time search compute. And then the reliability of the agent just shoot through the roof. Because instead of, in practice, what was happening before was without the eval agent, at each step, the agent is just guessing, it's like, probably that's the right one. Like, maybe we should try that. Like, but then once, they had enough traces in production and they'd run like the agent like 1,000,000 times, and they had user feedback data and everything, they're like, dude, we can now tune an eval agent off of this data. And then they tune that, and then they throw it into production with the agent. And now it's like,
and it's helping it make the best decision. So the production agent is like generating a bunch of different possible paths. And then the eval agent is saying, maybe is scoring or weighting those and saying like, pick this one. It almost conceptually to me sounds like training a reward model.
Yeah, but it's not a model. Like, see, you asked earlier about fine-tuning specific models, right?
Yeah.
And maybe that's a way to tune reward models, or, prompt hack, or, use few short, like positive, negative examples.
Full system.
Yeah, just like, I'm going to say, just no, okay? None of those approaches are going to work, right? People are going to try it. They're going to, sell it. Like, I just don't care. I don't think it's actually going to work. Like, when an LLM evaluates another LLM, what you care about is its explanation. The number is whatever, dude. Like, I just think like the number is like, okay, it came up with some number, but it always comes up with some number. You know what I mean? Like, it doesn't actually have a tuned, calibrated mechanism somewhere in its net, which is telling it only pick this number, right? It's just like, oh, that seems like a good token to me. Like, it's what you're really tuning is the explanation, the criteria that your evaluator judge is using to inspect other LLMs. And to make that criteria and explanation very detailed and very thought through, you will end up creating a multi-step pipeline. How will you not? right? Like, why are you trying to overload so much like cognitive work is how I like to think into one
Yeah.
LLM call. Just don't
Yeah.
do that. Like
Yeah.
split it
Yeah.
into multiple calls and then you'll go through the human evaluator tuning process and, the human and the eval system will riff with each other. And once it's all aligned, you can then constantly keep aligning that thing and that thing will align your end agent. So that's kind of how I roughly feel about it. Like I find like explanations that the LLMs generate are the more useful thing of LLM evals. And
Interesting.
you
Like
want to
even more
tune
than
that.
the objective score or
Yeah,
whatever
it's a score.
classification.
Yeah.
So what we're trying to, I mean, ultimately what we're trying to align here is the LLM generates something that the human agrees is the right thing. So we want, it's like aligning the LLM output or result with human desired output or result
Yeah.
alignment. So what I'm hearing from you is when you're building your judge LLM or realistically your judge AI agent, you want to have the judge LLM steps explain their thinking, explain their rationale for why they feel that this output either meets or fails the criteria, and then align that rationale with the same human's rationale? Is
Yes,
that
exactly. Exactly.
that is
Because the
fascinating?
way, the way
That is
the
insightful.
Yeah, like the judge, because that's the problem, right? Like you don't know how it's coming up with the score. So you're like, tell me how you're coming up with the score. I was like, this is how I'm coming up with the score. Then you're like,
Yeah.
no, just no, that's not the right way to think about it. And then the human goes like, think about this failure mode, think about that failure mode, think about this. And then once it's rational and you're rational when you're reading a traces line, boom, now you have an aligned system.
Yeah.
Now,
That is
now you're like,
that is insightful. That is
yeah,
amazing.
yeah. That's why I'm like, I'm really, really bearish on like people tuning judge models. Like, I think it's kind of useful for like, getting away from calibrating the scores and making them seem more realistic. But at the end of the day, like, are you being real? Like a judge LM will work across finance, healthcare, insurance, like, I don't know, like, structural engineering, civil. Like, is
Yeah.
that
Or are
really
you
the
just leading the
claim?
model to give you the output that you want, so to
Yeah.
speak?
Yeah. Like fool the human long enough, kind of.
Yeah.
Like,
So how do you generate that those reason traces? Is it just like literally prompting before with like chain of thought, and
yeah,
then
chain of thought.
like give me the
Yeah,
output, give me the score, but then like how did you come up with that score, LLM? Is that how you
yeah,
do it? And then just align those thought traces with the human's
short
judgment?
traces. Yeah. Like you start with simple chain of thought, few short. Like I think, yeah, if you do like 3 short chain of thought, that's like a good starting LLM evaluator, and then you can read its explanations and be like, most of the time, actually, the LLM teaches you new ways of thinking about your system. That's just what I love
Yeah.
about doing AI engineering. Is
Yep.
that AI is teaching you how to engineer it half the time.
Yeah,
Like, and so then you
absolutely.
read the explanations, like, okay, like this, but then sometimes it starts like considering things in its judgment where you're like, dude, this is like totally irrelevant, right? And then you create like, okay, then you get this sense of like, okay, maybe I need to run 2 eval prompts, right? One which is looking at this dimension of the performance, one which is looking at this dimension. And I need these two to kind of think independently so that either of them don't get
Influence each
distracted.
other.
Yeah. And then have a final step, which takes the two. Then final step, you can do like a, average or whatever, maybe add another LLM step to put all the facts together. This all comes down to the complexity of your original application and how
Yeah.
multifaceted is the eval. So yeah, in practice, I think a really good few short chain of thought, you look at the explanations, tune those, then add more and more steps when it's clear that when you understand yourself actually what you're evaling, because half the time that's what I'm telling you. Problem with eval is people just ship stuff. They don't know what they're doing. They're just like,
Yeah.
yeah,
Yeah,
I'm
writing
getting,
evals forces you to think about the problem,
yeah,
and solve it up front. Drew, I
yeah,
know we're about out of time here. I did
yeah.
want to get one last question over to you really quickly. What are some of the best resources to learn more about how to, build these high performance, robust evaluation systems? Do you have like communities or online resources that you recommend? I know that you noted Eugene Yan earlier. Like he's my go-to, but
Yeah.
any
He's a
other
G.
thoughts there?
Yeah, I think Shreya Shankar's Eval Gen work, that's obviously like top of mind. I think second is Eugene Yan's work around evaluator tuning. I think there is a big gap in the literature around how to do good synthetic data generation for evals. That's
Yeah.
like no one's attacked that problem. I'm really surprised by it. In terms of like how we kind of think about it, I'm actually working on a blog post now for building robust evaluation system. So hopefully when that's out, I can refer to that based on all these learnings that I've kind of talked about today. But yeah, we have like we have the HoneyHive blog where we have some basic stuff written out about this. But yeah, that was written like a year ago. So I think
Sure,
a lot of
a lot of
learnings.
learning since then.
Yeah.
Yeah,
I'm trying to
I'm kind of doing
think.
the same where, I'm learning from you. I'm having other conversations with, experts in the eval space, and I'm going to be building kind of a write-up as well.
Nice. I would be really interested in reading that.
Absolutely share it out to you.
Yeah.
But speaking of, our audience, finding good ways to connect and learn with you, what's the best way to reach you for casual conversations, serious conversations? How do people find you online and actually connect with you?
Yeah. No, I'm always down to talk to people. Just reach out on LinkedIn for sure. That's the easiest way. That's the most reliable. And then, yeah, email is also works. Like I'll send a calendar link immediately if you want to riff about evals, because, oh my God, this is my pet problem. Like, I think this is a long-term thing. It's going to be a 10-year journey. I think it's not going to be a short-term thing. I think I didn't get to call out some of the work coming from Eleuther AI. Yes, the best resource actually for learning about evals is Eleuther AI's eval paper. I'll send it to you after the call. They synthesized all their learnings across, dude, like they are the go-to eval harness for judging LLMs. And they've been running a ton of harnesses. Their research and learning is like a 100-page doc. It's just the best to learn about evals. I don't know one talks about it. And I'm like, these guys have done more evals than anyone else.
Dhruv, this has been incredibly wonderful, incredibly insightful, especially at the end there with talking about the parallel, your production AI agent and your evaluation AI agent as well. That was like incredibly insightful to me. I want to thank you so much for carving out some time to chat with me and teach me and ultimately our end audience here. It's been great, man. Appreciate it.
No, I mean, thanks a lot. No, thanks a lot for the really good questions and for hosting this, because yeah, I mean, the more people talk about evals, the better. Because again, like I feel there's so many gaping holes. Like at HoneyHive, all we've been doing is building the basic plumbing for running evals reliably. But I feel like there's still so much work to be done around how to design good test cases for evaluations, like the different kinds of eval agents you can build for different kinds of domains. Like there's just so much greenfield space, but it's just so easy to ship something to prod with no evals. Like that's why the eval research always falls behind, is how I feel. So thanks for doing this.
I was gonna say, I think it's starting to catch up though. It's like last year everyone was excited about all the demos. This year reality is starting to hit people in the face, and I think it's made evals an incredibly hot topic.
Awesome.
Whenever I was at GenAI or AI Engineering World's Fair earlier in the year, like everyone was talking evals, because it's like, how do you build actual production system without evals? And the question is, you don't build good ones.
Yes.
It's been an absolute pleasure. On that note, I'm gonna let you get back to it, man. Thanks, man.
Yep. Thank you. See ya.